In this experiment, we will use a redox reaction to test for the presence of alcohol. Dichromate was once very commonly used in breathalyzers as it changed color upon interacting with alcohol in the following reaction. Ethanol reacts with the orange dichromate ions to form acetic acid and green chromium 3+ ions. To monitor this reaction, we use UV-Vis spectroscopy. Using this technique, we can observe the change in concentration of dichromate. If we know how much dichromate we started with, and also know how much dichromate we're left with when the reaction was completed, we can figure out how much ethanol was in our sample. UV-Vis spectroscopy works by shining a certain wavelength at a sample and measuring how much of it is absorbed by the solution. The basis of this technique is that different wavelengths of light interact with different molecules. Our solution appears orange when we shine white light at it. But why is that?
The color of light depends on its wavelength. White light contains all wavelengths of the visible spectrum. You can see the different colors if you shine white light at a prism. When light interacts with a solution, some wavelengths will be absorbed while others pass through the solution. In our case, blue light is absorbed, which means the remaining light appears orange. The color of a solution depends on the light it absorbs. This color wheel shows the relation between an absorbed wavelength and the resulting color. So for a solution to be orange, it absorbs blue light. The same is true in reverse. If it absorbed orange light, it would appear blue. If the solution absorbed green light, it would appear red, and so on. To measure your solution in a spectrophotometer, you will need to pipette it into a cuvette. Note that the cuvettes have a clear side and a frosted side. Only handle the frosted side of the cuvette to avoid smudging the clear side. Carefully fill the cuvettes to the line with a disposable pipette. The first thing you'll need to do is blank the instrument. A blank is made up of only the solvent you're using, but no dichromate. Open the covering of the spectrometer and insert the cuvette. The white line shows the direction the light travels in. Make sure that it lines up with the clear sides of the cuvette. Ensure the cover is closed after you've inserted the cuvette. To set the wavelength, press the lambda button. Then enter your wavelength, for example 450 nanometers, and press enter. The spectrometer will now set the selected wavelength. Note the readout, it is not 0. To set it to 0, press the blank button. The absorbance should now read 0. Open the sample compartment and insert the sample with your dichromate solution. The instrument will now display the absorbance of your sample. Wait until the displayed value has stabilized and write the value in your lab book. To make your solutions, you will have to use a graduated pipette. The pipette bulb has 3 buttons: the A valve to release air, the S valve to siphon liquid, and the E valve to empty the pipette. First, press the A button and squeeze the bulb at the same time to force the air out. Then, press the S button to siphon the solution. Finally, press the E button to empty the pipette.
Before you can prepare your samples, you need to calculate how much stock solution is needed for each of your 5 standards and pipette the required amount into a volumetric flask. Be sure to wipe up any spills. Once you've pipetted out the required amount of dichromate solution, fill the flask to the line with 2 molar sulfuric acid using a disposable glass pipette. Once the flask is filled to the line, insert the lid and mix thoroughly by inverting the flask several times.